Test. 1, 2, check. 1, 2, 1, 2, check. How is... I don't know what I'm saying. 1, 2. How is my audio? How is my audio relative to the music that you're hearing? Should be live in just a minute or two. Check 1, 2. Testing the sound again. This time for real. I think everything is working. All right, here I am. Here we go. Bow, 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 bow. Polar to Cartesian coordinate song. 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 Hey! I'm here! Welcome to... Oh, no train whistle, no bell. Where did I put these things? Pickle! Pickle, I have a new sidekick. You can't see my sidekick. I gotta get a sidekick cam. I have this whole extra camera here, which will allow you to see my little sidekick cam. But, oh, wait, where are you going, Pickle? Ah, I don't know where I am. I don't know my buttons. All right, wait a sec. Oh, there we go. Excuse me, everybody. Hold on a sec. Can I start over? Let's start over. We're gonna start over. Okay, Pickle? All right. We're putting on this music. We are going back to the opening screen. And coming to you live from Brooklyn, New York. It is the Coding Train with your host, me, Daniel Schiefman, and his coding buddy, Pickle. Oh, hi, Pickle. Okay. Welcome. All right, I'm back. I'm attempting to get back into live streaming. It's very hard for so many different reasons, and I know everybody around the world is dealing with so many different kinds of things, and I hope that me just being here, possibly once a week, if I'm lucky, maybe even more, making some coding tutorials, saying hello, bringing some sunshine and cheer, and ridiculously... Well, the music is actually quite excellent. My interpretation and maybe my use of the music, I could do a better job of, but, here we are. I've got a green screen. That's a little upgrade for today. I've got a one of these blue microphones. Tap, 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 tap. Yep, that's working. I have a headset, which currently there's nothing going on in here, but if I had a producer, they could, tell me when I'm getting things wrong. Like my physics formula is off and my code is broken. I could hear them in my ear. So you eventually could talk to my ear. If things go well, it's 4 p.m. Eastern time right now, and we can make it till, 5:30, 6 o'clock, an hour and a half or 2 hours. Towards the end, I might like to see if I can answer some questions. I got to introduce you to Pickle. Pickle. Pickle is sleeping so calmly here on the floor. I think it's worth it. Here, okay. Come on. Let's see. Oh, all right. What's this gonna do? Here, where are we gonna go here? Let's see. There we go. Hi, Pickle. Say hi. Oh yes, it's my little baby. There she is. Oh, what a good girl. Good girl. Yes, we're going to do some coding train together. Yes, good girl. Good girl. Good girl. Okay. Putting this camera back wherever it was supposed to be, which is here. What's the chance this is in the right spot? Maybe this is where it's supposed to be. That's better. This is for my diagramming. And there we go. Erase here. Oh, wait, what happened to my soundboard? Oh, the battery died. Oh no, but it's plugged in. I should be getting charge power. Oh no. Oh, it says it's not plugged in, but it is plugged in. Let's see if things can come alive here. Come on. All right, I have no soundboard right now. Sorry. That's right. That's a good girl. Okay. It's really keeping me sane. I lost my soundboard. Here I am. Oh wait, Mark Rober is live streaming right now. I thought that was at 4 o'clock on a Friday. Yeah, go watch Mark Rober. I'm just here doing that. I'm not even, I'm like sweating. It's warm in here. I have no idea what I'm doing. I'm going to do some coding tutorials, I think. And I'm going to be talking, hopefully, more than just like what I'm doing right now. Soundboard. I really feel... All right, I have another idea. Let's see if this works. Will this give me power? Come on, soundboard. You can do it. Okay. Plug in. USB cable. Which way do you go? This way. Upside down. Okay. There we go. I've got power. Okay. All right. Okay, Pickle. How we doing there? I definitely need another webcam. Okay. Wrong one. Here we go. All right. Welcome to the Coding Train. I am Dan. I am at home, as almost all of us around the world are. I am in New York City, and particularly in Brooklyn, which is definitely a scary and place to be these days. And I hope that all my neighbors are doing well. I hope that you're watching this are doing well. And I'm trying to get back into the rhythm of doing work. I teach classes at NYU. Those classes are happening remotely. My kids are here being homeschooled. They have some video calls with their teachers and classmates and work being assigned to them, but they need a lot of help and supervision, so that takes up a lot of time and energy. They need to eat all the time. There's a lot of feeding going on. So my weeks are just kind of insane, but we're here, we're happy, we're doing okay. And I found that last week I managed to finally sort of get around to trying to live stream. It was Saturday. This week's a little bit earlier. It's Friday afternoon. Who knows? Maybe next week I'll be back to Thursday. Something a little bit different. I have never actually done this, and I'm not too happy about it, actually. I might want to change, is that I'm sitting. I always stand when I live stream. I like to pace around, move around, jump around, just have that energy of standing, and it's kind of like, it lets me know that I am live streaming. I am performing in a way for the live stream. And right now I'm sitting. So I'm not so sure about that. But I'm gonna sit for a little bit. I also actually, it's looking fine. I have a secondary light. If you look at this, there's like a pretty good, decent shadow here. I have a new light which is coming from this side. I have a new polarizing filter on my camera, which I think is helping with the reflection in my glasses. I really wanted to eliminate the reflection in my glasses, which I think I have done a pretty decent job of. I don't know. I can't actually tell because when I'm looking at you, I can't see my monitor over here. But I do have another light. This is the Emperor's new light here, but I have a light that I could attach to here. I was gonna put it right here and try to fill in the shadow, but I'm not gonna worry about that right now. I also need to figure out about recording to disk, so that if anything that I do today has any value whatsoever, that I could work with Mathieu, who is the editor for the Coding Train, and put together a video that would get uploaded separately afterwards. For example, I'd like to try to do a coding challenge today. I have my whiteboard over here. Wait, that's weird. Am I smaller? Oh, no, that's fine. This is what it should be. And then this just goes to the full camera. There we go. So let me think about this. How am I going to work this? Do I have my soundboard back? Everything will be fine once I have my soundboard back. No, it's charging though. It's charging. Charge on up. Charge it up. Search it up, people. All right, watching from Iceland. That is amazing. Hello, Iceland. Let's go to here. I think we should do some wheel spinning today. I think we should just start with a wheel spin. Worley Noise. These are things that are in the sort of pipeline. Marching squares. What are some other like algorithms that I have not programmed recently that could be fun to do? I guess I could just pick between these two. I should just do Worley Noise. I shouldn't fit the wheel. Let's take a look at the coding train suggested topics. This sitting thing is really weird. I feel so low energy. We've got some new ones that have been opened up recently. Two-dimensional discrete Fourier transform for images. Didn't I do that? Or maybe this has to do with image processing. Visualize common math algorithms. Particulated pi. Let's see. Let's look. Often I assign them to myself when I feel like it's something I'm going to do. Autoencoder. I could just do that. That would be fun. Fibonacci spiral. I think I kind of did that already. I've done a lot of these. These are the open ones. A lot of these have been done. These are the two that I was sort of most recently thinking about. Let's do Worley Noise as just let's forget about that wheel spinning thing. I'm gonna get to the wheel spinning. Tetris. Let's do a coding project that is like totally manageable. And ooh, look at these images. That is manageable. That will give me a pattern like this. This might look like a lot of these look like a Voronoi tessellation, which there's Worley Noise, which is a variation of, which is a kind, it's named for Stephen Worley, but it's really cellular noise, which can be. Depending on how you implement it, it's basically you're getting this Voronoi tessellation, which is another coding challenge that I should do. But look at this one, interesting. Gizmos and games. But there's some ways to get some interesting variety. Look at this. I don't actually know how to get it to look like that. That's interesting. I feel like this, I've seen, ooh, look at this. These are interesting. All right. We're going to attempt to do this. I'm just like launching right into it. I'm going to open up processing. This is going to be a test. Now, I need to record to disk. So I'm going to press this button here, and I'm recording to disk. I want to attempt to also record. I want to attempt to also record the green screen separately, and the software that I do that is here. And give me a minute here. I didn't get a chance to do this in advance. Talk amongst yourselves. Let's see. How do I create that virtual? Oh, let's just do. Is there audio coming in? No. There might be though if I do this. Audio. Oh, this is audio settings. There we go. Audio settings. It's getting some audio from, interestingly, from the camera itself. I need to create a virtual camera. And I don't remember how to do that. New, add input. I'll be back in a minute. Sorry, I'm setting up some configuration stuff so I can record this green screen on its own, which maybe is not really gonna video. Browse, blank, browse, more. Virtual set. No, that's interesting. Video, image, camera, virtual camera. I know that's the one that I want. Desktop capture. Virtual set. I don't think virtual set is what I want. Camera. Oh, I should have done this in advance. Definitely should have done this in advance. I've done this before on my other streaming computer. This is fascinating. Go watch Mark Rober's stream. Come back in just like 5 minutes. Tell me what's going on in there. Maybe I could do, is there something that he's teaching that I could do a coding version of? Input virtual. All right, I got to look this up, people. I'm looking up on my vMix virtual camera. Is that not what it's called? I guess I could just try to record this audio. Maybe I just need to do, I know, I have an idea. Add input settings. All right, I think I might just have to record NTSC 2997, that's right. Audio. Recording. All right, let's just hit record and see what happens. Audio mixer. Oh, there we go. Inputs. Game capture. No. I want to add an input. Oh, I know. That's what I can do. Add an input. Audio. There we go. Browse. No. Audio, but not a file. Don't be ridiculous. Sorry, everybody. This is what happens. Audio input. More. Audio input. There we go. Add device. Yes, the microphone is exactly what I want. Okay, yes, there we go. I've got my microphone audio. There we go. Now I'm going to do record. Oh, uh-oh. It is, the monitor is on. Okay, well, that's okay. I can just mute this. Do you hear that weird echo? You're going to get feedback too. Okay, there we go. That's good. Now I'm going to hit record. And output 1, that's fine. MP4, that's fine. Let's just try that. New file every, let's say every 30 minutes. And okay. And am I recording? I'm recording. Okay. I'm recording. Oh, look at me here. Okay. All right. I have to live stream today. I made a last minute decision. I'm just going to do it. I'm just going to live stream today. Mark is doing a full-on physics class on how to weigh stuff without gravity, complete with what I believe will end up with differential equations. Well, I would say Mark is doing an excellent job without having watched it. Probably well rehearsed, prepared, not just configuring settings on another computer that's over here. I'm so sorry, everybody. This is not going well. All right. Worley Noise. Tweaking of seed points and colors would be necessary to make this look like stone. Whew. Whew. I also need to record separately a screen capture here. Let's see how that works. New screen recording. Record entire screen, record. Okay, so I think I'm recording now here. I want to get the paper out. Cellular texture basis function. 1996. Nth closest point basis. Okay, I think I understand how this works. We all want you to make Tetris. Should I just do Tetris today? I probably should. I'm going to come back and do Tetris. That'll be fun. Just not today. Whew, I need to open a window. Let's see how my batteries are charging. Nah. Okay. All right. Everyone, how's everybody doing? Good? Let's just give this a try. No, let's pick one. Ooh, oh my goodness, Pickle. Pickle is a little bit scared of my train whistle. It's going to be okay, Pickle. Q&A about why you haven't made Tetris yet is an excellent suggestion. All right. Yes, I got it. All right. Tetris with Worley Noise instead of colors. Okay. Yes, somebody's knocking at my door. Do I need to mute my microphone? Come on in. What's going on? I am live streaming right now, just so you know. Yeah. You want me to mute the microphone? Hold on. We've got to. Let's move to. Let me do this. And mute the microphone. Okay, I'm back. I don't know why my soundboard won't get any power. Should be getting power. Let's see if it can come alive. We're getting started in just a minute, don't worry. This is no professional operation like the Mark Rober live stream. Just this is a very unprofessional operation that I'm working on here. Have I lost all the viewers yet? No, I seem to be gaining viewers. I don't understand how that's possible. Okay. I doubt this is going to get edited into anything later, but it's a good practice. All right. Welcome to a Coding Train Coding Challenge. Okay. I don't know. Hi, Bruno. Yeah, I sort of felt like I should do one of these SIR models, which I think is interesting to look at, why, how an infection spreads, how social distancing or physical distancing, whatever term you want to apply to that, can slow that spread. And there's an excellent visualization in the Washington Post on that from several weeks ago. 3 Blue 1 Brown did a video. Simon Tiger, has done one, and I don't know. I don't want to do something that I really have no real knowledge or expertise in. I'm not sure what I have to add to that discussion. So I think I'm just going to go with my usual stuff, but I will consider that. Everyone's giving me some encouraging words. All right, here we go. Hello and welcome to my first coding challenge from home, a new sort of studio setup that I have. Looks kind of like this. I don't know how this is going to go. I've got a green screen behind me. I'm sitting, which is really kind of a problem in terms of I think the blood's not flowing to my brain properly. I should probably stand up. But what are you going to do? What are you going to do? Here I am. I'm going to attempt to program Worley Noise. What is Worley Noise? What's the algorithm for Worley Noise? How can you program Worley Noise? And can I get an image? And I can't seem to point over there because I have this little tiny area for myself. This is not good. I do not like this setup. I don't like this setup. I don't have a soundboard. I made a mistake. I should have taken a nap. I'm gonna go ahead and do this anyway. All right. Woo. Give me one more try. Again, this is a test stream. This is not my actual Coding Train live stream. Move the camera. Yeah. Hello and welcome to Coding Challenge Worley Noise. I'm going to attempt to program this algorithm that I found over here. Move the OBS camera. Yeah. All right. I promise you that I'm going to get used to this and I'm going to get the momentum going. If this is your first time watching, I'm very sorry. If this is your second time watching, if you're watching, I'm sorry. I think I can manage to bring myself to start to code an example. I just need to get over some sort of like mental block that's happening to me right now. All right. 4:25 p.m. All right. Hi, Poland. We didn't get a 1 million special. I know. I'm having trouble. Welcome to a Coding Train Coding Challenge. I am recording from a new studio setup, so things might be a little wonky, but I'm going to try to make this video. I'm going to try to program this Worley Noise thing. I'm here in Brooklyn, New York at home with some lights and a camera and a laptop, and I'm sitting, which is really weird, and I don't know why I'm sitting, but I should be standing. I like to stand while I code. I'm sitting. Everybody just take a deep breath with me. And let's try to make something fun. Let's try to make something beautiful. I'm going to make a very simple version of just this algorithm, and I don't think it's going to take that long. And from there, maybe you can make your own creative twist on it, share it. We can, and that'll be that. That'll be something. That's a thing we can do to learn something, to enjoy ourselves, and to be together through this medium of the internet video through a lens thing. Is my soundboard back? Come on. No. All right. I have to give up on this, and I've got to plug it in. I've got to plug it in over... Ah! Camera's falling. Oh, no. Do you hear a weird... Can I turn on slow mode? Not easily right now. Not easily. I'm going to plug this in over here. I really should have charged this in advance. Come on, my little baby. Pickle, right this. You're going to come sit with me. Oh, you're such a good doggy. Okay. This is going to make everything good. Whoa, no. Okay. Oh, I know. Okay. I think she's not used to being on my lap. All right. Okay, ready? Okay. Here we go. We're going to try this one more time. It's nice that everybody is always leaving me friendly comments in the chat. All right. Here we go. Welcome to the first Coding Train Coding Challenge from home. Gloria, Pickle, and I are really into this new algorithm called Worley Noise, and she suggested it. I think so, at least. Her nose kind of pointed in the direction of Worley Noise when I was looking at different web pages, and I thought, let's program it as the first coding challenge from home. I've got a new setup. Things are probably going to be a little bit wonky. I'm just gonna do my best. Honestly, like if I'm recording this during a live stream, I don't know if this is ever gonna make it into an edited video. If it does, I'll be shocked. But the poor people who are watching this live stream have watched me try to get started coding something for just like the last half an hour and I'm really having a difficult time. But I think my little friend here, Gloria Pickle, she's going to help me out. I'm going to be strong and get to coding something by now. I'm going to let her down. She's built like a tank, this one. Okay, go down. There you go. Good girl. Okay. You can go back to sleep, and we're going to get started. All right, so what is Worley Noise? I've got... Oh, shoot. What happened? My setup is all messed up. There we go. Oh, this is the wrong... Ah! I was doing so well. Does it go this way? Back? Yeah. Back. Back. Come on. Whenever I move, anything gets knocked, I totally, like, my whole thing is out of whack. Move this way. There we go. Okay, I'm gonna get this. Okay. So what is Worley Noise? First, let's just have a discussion of what noise is. And I want to visualize noise in a two-dimensional canvas, in a window on a computer. And the way that I'm going to visualize noise being another word for randomness, is by setting every single pixel color of a two-dimensional window to some color. And I'll just do pure noise, randomness. I'm going to open up my processing window here, and I'm going to add setup, and I'm going to add draw. I'm going to make the window size 400 by 400, and let's run this. And I've got my window over here. I'm going to save this as Worley Noise. I'm going to draw a black background. And then I'm going to do a nice for loop. I'm going to loop over all the x's. And all the y's. I'm going to get an index. Hold on. Finally. How's the typing noise? It's good? Yeah, I know. Processing. Okay. So here I am in processing. I am going to write setup and draw. You know what? I don't think this needs to be. And then this is how I get that there. Okay. How's the font size, by the way? I'm going to make this project in processing, and I will also release a JavaScript version of it. But because I'm going to do this operation pixel by pixel, it can be very slow in JavaScript Canvas. So without worrying about optimizing it right now, I'm just going to stay in a desktop environment, processing built on top of Java. So I have a setup function. So I have a setup function up there, which gives me my window size, 400 by 400. And in the draw loop, what I want to do is set every single pixel. So every single pixel in the window is going to have an X, Y location. And I can iterate over every single pixel with a nested for loop. Oh, I want these to be X's. So this loop here looks at every single x and every single y. Then what I want to do is set every pixel at that x and y location. So pixels index something to a random value. So I have to figure out the pixels in a processing window are stored, the colors are all stored in an array, a one-dimensional array. So I need to know for any given x, y, what is the index into that array. And there's a nice formula I can use where the index is x plus y times the width itself. Now, this is something I've gone over countless times, but I'm just going to go over it again in this particular video. Let's say that I have my window that has 1, 2, 3, 4, that's 5 by 1, 2, 3, 4. It's 5 by 5. Okay? And if I'm looking over here, the x is 0, 1, 2, 3, which is right here, and the y is 0, 1, which is right here. Now, if I were to count the pixels individually, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, how do I get this number? Well, it is how many over? Its x is 3, so it's 3 over 4, 5, 6, 7, 8. It's actually pixel number 8. 3 plus 5 is 8. Then this pixel would be 13, and this pixel would be 18, because we've got to go 5 more down every row. So the x value, 3, plus the y value, 1, times how many pixels are in each row, 5, gives me 8. This is the formula. So I can apply that formula in my code here, x plus y times width, say pixels index, and run the sketch. I'm curious, I'm missing a really important detail. Let's run it and see what happens anyway. Yeah, null pointer exception. Why did I get a null pointer exception? Because the pixels don't exist. I mean, they do exist. I see them. They're there. They're pixels. But they don't exist because I didn't... well, they exist. They're there. They're pixels. That's what I said. But I don't have access to them because I haven't unlocked the key to them in memory. And the way that I do that in processing is by calling the load pixels function. Pixel would be a good name for a dog. Sorry, Pickle. Her name is Pickle, not Pixel. I could call her Pixel as a nickname. Pixel. Hi, Pixel. Update pixels. I also have to say update pixels once I'm done with the pixels. There we go. So now I have noise. This is not Worley Noise. Don't be misled by the title of the window. I haven't implemented Worley Noise. This is pure noise, randomness. Now I just want to have it run once. So I'm going to add no loop here. So draw happens once. And I just get a random set of pixels. Load pickles. Load pickle. All right. Now, so what I've implemented so far is noise. But there are lots of other kinds of noise. I probably have at least 10 videos on something called Perlin noise. And a lot of people argue with my videos that are called Perlin noise is actually not really Perlin noise. It's fractal noise. Or maybe it's gradient noise. Because Ken Perlin revised Perlin noise to something called simplex noise. But simplex noise, there's a sort of interesting history to that, but I was using in a different video, open simplex noise. And what all these different kinds of noise algorithms are, they're all rooted in randomness at their core, but something different happens along the way. What I've implemented here is literal just randomness. The only algorithm is pick a random brightness value between 0 and 255. But each one of these has a different kind of twist on that. With Perlin noise, the idea is really to create a smooth noise. And you get these nice textures that appear like clouds or marble, and you can do a lot with them. So I would love in my life to implement every kind of noise that ever existed, and I've done some of these in different videos. I haven't necessarily implemented them, but I've made use of them. But in this video, we are going to do Worley Noise. Another name for that is cellular noise. Okay. Worley Noise was named for Stephen Worley in 1996, and there's this actual paper, a cellular texture basis function. So I encourage you to pause this video now and enjoy reading this paper. I would love to do a dramatic reading of it for you, but I'm not going to at the moment. I'm just going to stick to something very, very basic here, which is just following what's literally written. I'm going to make my own rather than read the paper all the way through and try to follow that to build Worley Noise, I'm just going to follow this summary, simplified summary that's on the Wikipedia page. And there's really just two steps to this algorithm. Number one, randomly distribute feature points in space. And I could use a two-dimensional space or a three-dimensional space. And actually what's interesting about this is even though what I'm drawing here is a two-dimensional space, every pixel is in 2 dimensions, I could think of the Worley Noise space as 3-dimensional but visualize a slice of it. I think that's the way I'm going to start this, to be perfectly honest. So if I go back to Wikipedia, the first step is randomly distribute feature points in space. Well, I'm going to make an array of p vectors. We'll call that the features. Let's just make 5 of them. And make each one a random point. So each point has an X and a Y and a Z. Now, the range of what the X and Y are clearly within my two-dimensional canvas of 0 to 400. I'm just going to consider it to be a box, a cube, where every dimension, the width, the height, and the depth is all the same. So I'll just use the width for the Z. Come on back to me. Then just to understand that this is working, I'm going to comment this out, and I'm going to draw all those points. Let's skip the Z, actually. And I'm going to set a background so we can see them. There we go. Each time I run this, I'm going to get a new set of points. Now, I'm not so worried about visualizing the Z. An interesting thing I could do is I could say, let's make the stroke weight, we'll map the features Z, which has a range between 0 and width, and I'll make that between 1 and like 12. So that way I can sort of see, depending on the Z value, it'll be a larger or smaller point. So you can see what's going on here, as if this one is closer. Now I'm not rendering this with any kind of 3D perspective. I'm just trying to get a sense of what the data is. So now that I have that, the next step is f of n x is distance n closest point to x. What does that mean? I don't like my lighting. My lighting seems weird. What's the... There's a lot of people watching this right now, which is giving me a little boost of energy. This is, by the way, a nice little coffee mug here. I guess there's some green in it. But this is drawn by my daughter in her art class. Can you put your laptop up? You're looking down, which is weird. Yeah, and I've got this hat on too, so I'm probably doing this. I should stand. Should we move to standing? It's too late. I should move to standing. I should move the camera back. I should move to standing. Okay. Should I try to do this slow mode thing? Because I can make that happen. How's my? Let me see how my soundboard's doing. 12%. It's up to 12%. That's pretty good. Okay. All right, here we go. How are these batteries doing? Okay, that's not so bad. Okay. Remove that because it's the Orioles. No! I'll tell you something. Baseball is canceled, which means the Orioles are tied for first place. This is their year. I think they might finish the year tied for first place. Okay. Move to standing, please. All right. What part of this was I on? All right. I'm trying to understand this. Noise. F of n of x is distance to n's closest point to x. See, this shadow behind me is really bothering me. We're going to get rid of that shadow. Okay, we're making it happen, people. I'll leave a couple of these in here. Sharpening still. There we go. If only I had a soundboard and I could play some music. The Worley Noise thing is I'm gonna continue that in a second. Don't worry. This is gonna get good soon. Let's just see here. Let's see here how this goes. I have these rechargeable batteries that I've just charged up. I'm gonna attach this light here. Well, let's make sure it's actually gonna turn on. Ooh, that's pretty bright. Okay, that's good. I don't know how long it's gonna last, but. Okay, here we go. Is this helping anything? How's that? How am I looking? I don't know. There. Let's, weird. What's going on with... I don't know if that's better. Maybe I should just have this light over here. I've got light from two sides. All right. I don't know. I haven't really improved anything, but that's what it's going to be. All right. Okay. Where's my marker? So I have my noise space with some number of seed points. Now, what I want... The next step is for any given xy point, which I guess is just really called x here. So for any given x right here, the noise function of x, so I could have an f of 1 of x, I can have an f of 2 of x, is basically equal to the nth closest point. Meaning, this is maybe the first, let's draw these points in a more obvious way. And then I will number them. Where's that other? So we have this point, this point, this point, this point, and maybe, I don't know, another point over here. So this is the first closest point. This is maybe the second, then this is the third. I don't know, I'd have to get out a ruler. Let's say that this is the fourth, and this is the fifth. So the idea is, I can choose a different n, but for any given n, I want to color this get a random value. It's not it's random only because these seed points are randomly distributed. But now that those points have been distributed, the color for this particular pixel is specifically a function of the first closest point, the second closest point, or the third closest point. So going back to the code, and let's make these red so that I'll be able to see them more easily. Let's put the pixels back in. Just make sure everything's working together. Let's make these points a little bit larger so I can see them better. So now I want to look for every given pixel which point is the closest. Or actually, I don't necessarily. For every given pixel, I want a sorted list of the distances to all the points. So right here, I'm going to create an array of distances. Which is a new array. How many values need to go in it? The same number of values is the same number of seed points. So features.length. Then I need to loop over all of those. Let's get the distance between, oh, actually, I need to store the distance between what? Between the X and the Y, the given pixel that I'm looking at, and the given feature point that I'm currently on in terms of this iteration cycle. And actually, we want to keep the Z here. So these points, I'm just looking at a slice where Z is 0, but I want the X, the Y, and the Z of all those feature points. Then, you know what's lovely about this? I could just sort them. Because it's just an array of floating point numbers. The processing has a sort function which knows how to sort an array of numbers. So I could just say sort the distances. I wonder if that makes a new array. Well, we'll find out. And then I just need to get that distance. Let me get the closest one. So this is if n is 0. So just to have everything named correctly in my code, let's create a variable called n and set that equal to 0. So the distance, I want to look at the nth closest distance in the array. And then set that to be the color. Interesting. We can sort of start to see little circles that are going on here. Now I need to deal with a mapping here. The mapping is way off, right? Because what's the range of these distances? Well, it's somewhere between it really depends. The cube is the width, height, and depth is all equal to 400, or width is the global variable. Let's use a mapping. So let's call the brightness, I'll just call that B, is map the distance, which has a range, let's say between 0 and width divided by 2. Let's just take half of that. And when it's really close, I want it to be super bright. When it's really far away, I want it to be super dark. So let's make that the color for every given pixel. What did I get wrong here? Got something quite wrong here. Map distance. This looks good to me. If I run it again, will I get a different result? No. Oh, wait. I wonder if... No. Features. Distance. Sort. Brightness. B, the index. Yeah, this looks the X, the Y. Let's get rid of the Z for a second. Oh. I guess my range is really off because of the Z, this depth space. Oh, you know what's going on here, I think. I think the sort function in processing is making a new array. Yes. Okay. So the sort function, this sort function was sorting the array, but it copies all those distances into a new array. So that array wasn't actually sorted. So I need to create I need to take the new array and set it equal to itself. And now let's put the Z back in. Oh, well, this is 0. It's just that slice. There we go. That makes more sense. Let's create a lot more points. I'm just curious. People in the chat are very upset with my wasting of memory. Well, you know, life goes on. Interesting. So I don't need to draw the seed points anymore. So this is what I've got. It looks a little bit strange, mostly because of... Mac has said I'm not upset. Good. Yeah, I'm going to worry about the memory stuff in a bit, but this is good enough right now. So this has a kind of strange, almost spherical-like quality to it. It's because I started with this 3D space. And once again, let's go back and let's just have 3D seed feature points, 2D features. So if I get rid of the Z point, now I have, you can see this looks much more like a Voronoi tessellation. Because literally what we have is every point is colored according to its closest, to the closest point. We have, this looks exactly like a Voronoi tessellation because the definition of a Voronoi tessellation is cells cells that are divided by the dividing line where all the points in this cell are closest to a particular seed point or feature point. You can kind of see these. Now, because I'm coloring them according to the distance, you get these kind of like glowing little spots. And what's interesting about this is right now, and I don't know, I don't know what the frame rate is here. Let's take off no loop. And let me just print the frame rate out for a second just to see, am I even going to possibly get a reasonable animation here? I'm kind of running, you can't see this because I'm covering it, but I'm running at like 5 frames per second, which is terrible. Let's go down to like 400 by 400 and just 25 seed points. There's lots of things we could do to optimize this. And I've got 30 frames per second because what I want to do now that I think will be fun to look at is what happens if I go through and do this same loop where I look at all the points. And move them around randomly. I'm going to do essentially a random walk with each of them. we can see what's happening, right? If those points move around, the Worley noise is adjusting. Now, I haven't done anything having them move smoothly or with any kind of thoughtful behavior, but you could start to imagine if these points were moving with a flocking system or any other kind of thing that I've done in this channel. It's pretty interesting what we've got. Let's go back to the 3D features. I guess the distances are much greater. Why can I not get the 3D one to look like what I want? I think I know what the issue is. Whoa. Whoa. Infinity. Let's move these around again. Kind of interesting. You know, I guess the Z is so large that it might make sense to actually consider this something like, oh, because I'm at 0 also. Oh, interesting. You know what I should do? I should really, for this to make more sense, I should really have this be a number like this. Hold on. I should really have the Z range. Like, I want that slice to be in the middle of this cube that I'm visualizing. So I think that that would make more sense. And then I think it's going to kind of map. Yeah, so this is more like what I was expecting to see in terms of Worley noise, using a 3-dimensional space, like bubbles in a jar. Okay, I'm gonna let everybody watching this who's going to make their own version of this play with the motion, and I'm not going to worry about that right now. And I'm going to stick with a nice no loop to just run it once. Okay, so here's my Worley noise. Let's go back to 800 by 800. I'm going to double the number of points. I really should quadruple the number of points. Yeah, and here we go. This is the Worley noise pattern I have. Now, listen. Here's what's exciting about Worley noise. This is really the same as visualizing a Voronoi tessellation, but I've got an option here. Remember, the idea is that I'm taking the nth closest point. So what happens if instead of just using n at 0, what if I take 1? What if the distance is not, what if the color is not mapped to the closest point, but the second closest point? So let's have that be right here, n of 1. Look at this. We get a very different kind of pattern. It's very crystal-like. So this is another kind of texture that, you know, a lot of these algorithms were developed to make textures that would be applied to 3D objects. Ooh, that is really quite lovely. What happens if I change this to 2? Ooh, wow, it's even like more jaggedy. There's lots of possible things that could happen here. What if I change this to 3? Interesting. I have an idea. What if now I have an R, a G, and a B? So distance, let's name these D0, D1, and D2 for distance 0, 1, and 2. And let's use 0, we're going to use a different distance for the red, green, and blue component. So the red color will be mapped to the closest point, the green to the second closest point, and the blue to the third closest point. That's pretty interesting. Well, this is way more fun than I imagined it would be. I should probably do like hue, saturation, and brightness. Let's try that. Let's try color mode, HSB 255. And I could call these now HSB, but I'm now doing hue, saturation, brightness. So the hue is the closest point. The saturation is the, I'm going to rename this just because it's super confusing. So we're going to do this as HSB color. Pretty interesting. Pretty trippy. Trippy is what I'm seeing. You know, we could also do something where it's like plus frame rate, modulus frame count, modulus 255. So many ways I could like cycle through a sine wave here. I'm going to go back to the RGB. That was a nice little tangent I went on, but let's stick with RGB. Now, Lois is asking, can you control the drawn z-axis with the mouth? So what's interesting here is that I am fixing the z at 0. So there's no reason why I couldn't look at different slices. Remember, I'm looking at Worley Noise within a slice. I'm just looking at a slice of Worley Noise in a 3D space. So what if I made this mouse X? Now, unfortunately, this is going to render really slow. I'm sure my frame rate is really slow. Oh, I have no loop on. I'm also going to need to take no loop off. Let's go back. Well, let's leave it. Now, I'm guessing if I were to move smoothly, I would get a pretty... no, it shouldn't be mouse X. It should be... Z equals map mouse X, which goes from 0 to width to between negative width divided by 2, width divided by 2. So that's really the full range of Z, because remember, the 0 is the center of this cube, and in the Z and along the Z-axis at least. So I can see here, I could start to sort of move. Now it's a very, I think what I want to do is I want to reduce the complexity here and go back to 400 by 400 just to see if I can make this smoothly animate. Oh, that is really kind of nice. Let me zoom in on this for you. This is moving through that Z space. And I think it actually might be really nice to just animate this with a sine wave. So let me give myself an angle. And Z, rather than being mapped to the mouse, sine of that angle, and you know what, I don't need to use map, it's very simple. I can just take sine of that angle times width divided by 2, because sine oscillates between -1 and 1. And so now, let me just say angle plus, I'm just going to move the angle by a little bit. I'm missing a semicolon. Why is that running super? Ooh. I think maybe, you know, I don't know, maybe oscillation isn't as interesting as I thought it would be. No, this is, I was just moving too fast. Yes, this is what I was looking for. Should come back, right? Why did it stop? I mean, this doesn't need to be inside the loop right now. There's a lot of activity toward the center and a lot less activity toward the edges. I think I want the brightness to make this a little bit brighter. I don't know what a good strategy for that is. Multiply it by a little something? That seems silly. Whoa, that's kind of interesting. Some sort of an accidental additive blending effect that I didn't mean. Whoa, that's pretty interesting. Yeah. This is more like I was hoping. Just give it a little glow effect. And maybe I might prefer the blue to be, let's do it in the opposite. Let's have the blue be the sort of primary color here. And the red be the secondary and green being the third color. There we go. This is what I was sort of... And can I keep a sort of bare minimum of color? It really depends where the points are seated. What if I have many more points? So let's do something interesting here, which is, this is going to be very, very slow, but I'm going to, just to sort of see where we can get here. What if I make this 12, I'm going to make this like much higher resolution. Let's go 1920 by 1080. Now this is going to run super, super slow. But we can see this is kind of what the pattern looks like. But what I can do is I can save this out. So I'm going to call save frame. Worley, in processing, if you use save frame, and this is a directory path, so a folder and a file name. What this is going to do, it's going to name all of the, it's going to save every frame out as an image and name it numbered, 0000, 001, 002. You can just let this run for a little bit. And then I can render this to a movie file. Well, this is really picking up. Let's get the music going. I'm at 28% here in my soundboard, so I can hook this back up. I'm just going to let this be full screen. You don't need to see me right now. And we're going to let this render for a little bit. You hear the fan of my computer? Let me put the camera back on. So, I don't know if you can hear this. This is the mic. I'm moving it down to the... Can you hear that? That's what the fan of the computer is doing. Okay. This was really meant to be a coding in the cabana video. The keying is not so great here. No, whoops. Let me give you this. Actually, the other thing that's interesting is this is going to be a perfect loop. I just realized because the sine wave loops. Am I muted now? No. The mic's gone. It came back though, right? Am I still muted? Yeah, the mic is back. I don't know what happened with the mic. I think the cable is just loose. If you render the cube, you could set the alpha of every point that is black to 255, meaning you'll only see the spheres, which would be very interesting. Yeah, I should definitely try it, rendering this in 3D, because I would love to see that. I'm gonna take a short break and let this render for a little bit. Let's see how many frames we got. Oh no, whoops. So I wish I had been more thoughtful about this because I could make this a perfect loop. But we're up to 118 frames. How many frames? Someone do the math for me. If I'm going up by 0.01, a full cycle would be 0 to 2 pi. So, if does this calculator have pi in it? Scientific. Pi times 2 divided by 0.01. So 628, or approximately, doesn't 628 images? $628 frames. Where am I? We'll get there. Should have made it full screen, but $627. All right. You're a good girl. Yes, you're sleeping through this whole coding challenge. Solarliner in the chat is saying I can import the slices into Blender as a volumetric texture. Ooh, I like that idea. $520. She has just been sleeping through this whole time. We're gonna go for a nice long walk after we finish rendering this Worley Noise. Halfway there. There we go. Victor's asking where's the cat. Let me see if I can find the cat. There's two cats. Cats are sleeping somewhere else, far away from wherever I am. Oh, camera went off. It's not a Coding Train live stream if the camera doesn't go off. Wonder why that happened. Josh is asking, isn't it always at home? It is not always at home. Usually I record at in a studio space at NYU. Let's see, would we would we want to try this fancy Q&A thing that I've theoretically have possible now? Anybody want to call in from our supporters chat? We want to test the call-in capabilities. If you had a question about this you want to ask. Oh, was I getting... You heard a buzzing. I don't think I'm... Oh, yeah. I did get an emergency alert on my phone. New York City is seeking licensed healthcare workers to support healthcare facilities in need. Visit nyc.gov/helpnow to volunteer. Also, a brief rain shower will begin at 5:07 p.m. Oh, by the way, something that's exciting that's happening is if you're in the Discord, if you're not in the Discord, Jason Hegland, who is the illustrator for the Coding Train, let me see if I can get the Discord link to go into the chat. Did that work? I don't see it. There we go. Is working on some new emojis. So we're gonna have some new emojis in the Discord soon. Can you please say hi to my friend? It's his birthday. His name is Nick Kerr. So I don't know. What's your? I guess one thing I'm curious to hear is how is this? How's this vibe? I should change to standing up. Should I try changing to standing up and see how that goes? 400 frames. What number did we say we had to get to? 627. We're getting there. We're almost there. Almost there, Pickle. My little Pickle. Such a good girl. So what would be interesting, there's two optimizations that would be meaningful to do here. One would be to, one optimization would be to use a quad tree or a spatial subdivision, because to get the three closest points, we don't need to check all the points everywhere. We can register the points in certain quadrants. Another optimization would be to use shaders, frankly. And there are some good resources for doing Worley Noise with shaders, which I will try to pull up before I go. I don't know, I'm obsessed with getting all the way to 627. What time is it over here, asks Lemon. It is 5:23 currently. 5:24 p.m. Eastern Time. Let's see. Well, I'm going to let this keep rendering. But I think the Book of Shaders, which is a wonderful resource for learning shaders, has maybe a section on Worley Noise, possibly. I'm really filling up my hard drive here. Each one of these images is 2 megabytes. 2.3, 2.4. Are you going to render the cube? I would like to try that next. Yes. Definitely want to try that next. We're getting there. Oh, I hear the pitter patter of feet, which are not animal feet. There are other humanoid creatures that live in this house. I see one over there in this direction. She is approaching. The humanoid creature is approaching. Oh, nope, she stopped. She's doing something else. What's operator number 1 over there, I think? What's going on, operator number 1? All right, did we get there yet? Oh, so close, just like 25 or 6 more to go. So the I can't say the name in the chat, but why are the file sizes slowly increasing? So they're increasing and decreasing, and I think a lot has to do with just the there's a variable amount of color that's in each image, and whatever the PNG file formats require, like based on the number of colors or the actual pattern itself, the file size, I guess, gets larger or smaller. All right, we got up to 628. We can stop this now. I'm going to stop this. Let's come back to full screen here. Let's look at this folder. So in theory, we don't need these images. Let's look and see if our suspicion is right. This is image 628. And let's look at image 1. Did you memorize that image? Let's open this one. And then let's go to 628. Yeah. They're basically exactly the same. So let's get rid of 632 all the way to 628. Let's leave 628 just to be safe. And now, the next thing I want to do. So how do you render to a movie? So I have a whole separate video tutorial about rendering to a movie. And I'm going to, there's a tool in processing called Movie Maker. Let's grab that, Movie Maker. And I'm going to get this folder. Because I got to open this back up again. And if I just drag the folder in here, you can see that it is pulling all the files from this directory. I want to use the same size as the originals. I'll stick with a frame rate of 24. I will keep the compression as PNG. Why not? And I'm going to hit Create Movie. And we're going to save this. We're going to call this Worley. Now we have more waiting to do. Let's see what other questions I can answer. I could use HHRD as suggesting FFmpeg, which also could be used. It's going. This is faster, at least, right? Much faster. Come on. Oh, good. Good puppy. You're not a puppy. You're 6 years old. She's 6 years old. It's time to go for a walk. Thank you, Rock Respawn. Ooh. Uh-oh. Well, so much for that. My vMix crashed. Probably filled up the hard drive or something. Hope the stream is still working. So I see in the Discord, Kobe is setting up a way to manage some Q&A, which we'll just do for like 15 or 20 minutes, just really as like a test. So let's not get too overly ambitious. I definitely want to be done by 6 p.m. and start the weekend. I gotta get out. I gotta get outside for a walk. Pickle's gotta go outside for a walk. I gotta check on my children. But I wanted to test how it could work for people to call in via Discord and ask questions. So, because I have this headset, which I will be able to hear people, and I'll be able to send the audio from Discord also out to through the live stream as well. Okay, we are done. Let's see how this went. I can close this now. I can go to the desktop. And we have it here. Let's open it up. Oh, what? What happened? There we go. Oh boy. Whoops. I forgot that I've got Pickle here in this one. Okay, hold on. I'm going to give you a full screen view. Can I play this full screen? Full screen. I'm making an attempt here. Come on, you can do it. No? Can I export this to some... Convert stream. Let's try this. This looks good, right? I don't know. Save as a file. Let's choose another destination. Worley. Export. Save. Let's see how this goes. Let's see what we get. Almost done here. Okay, that's promising. Let's see if this opens with... There we go. All right, everybody. Ready for this? What's appropriate music for this? This is what we made today. Yay! All right, save. Oh, let's what? Let's save it as something else. Hey, that's only 5. I got this down to like a 5 megabyte video file. That's pretty cool. All right. All right. What are some other things we could try before I go? Before the Q&A. Before we attempt that. I'm gonna just freeze this. Actually. I think I'm gonna delete, or I'm just gonna move this to the desktop. And let me save as Worley Noise 3D. So what I'm gonna attempt to do now is actually visualize it in 3D. I don't understand exactly how I'm gonna do this, like do some kind of like voxel visualization. So let's see how I might do that. Yeah, so let's keep it the way it is. And I'm going to change this to P3D. I'm going to go back to just like 800 by 800. So this is what I get just looking at that 2D slice. And now I need a triple nested loop where Z starts here. This is Z. And let's have like a skip factor of like 10. Let's just do every 10th pixel right now. I need another, and I'm not doing load pixels and update pixels. Instead, I am saying push, pop, translate, what am I translating to? X, Y, Z. Why do I have an error here? Oh, because I have multiple Z's. We're going to get rid of this. X, Y, Z. And we're going to just draw a box that's of size 10. And let's give it a fill with an alpha. Just what do I see here if I do this? Okay. So that's what I was hoping for. Let's say no stroke. Let's make the skip, and this should be the skip size. Let's make the skip much larger, like 25. Okay, now let's try adding. Let's try adding the PZCam library, just so I can kind of view it. And the PZCam library allows me to sort of view this thing in 3D. So if I go, I'm just going to look under examples. Just get the basic PZCam example, which is just hello PZ is all I want. So I want to have a PZCam instance. Then I want to create in setup a new PZCam. I need the import statement up top as well. I have a feeling it's going to center everything around 0, 0, but let's just see what happens. Right, so now this is the 3D space, but I want to be sort of further out away from it. I think there's a way that this 400 value must be like how far away I am from it. Yeah, there we go. So I'm further away, but the corner, yeah, there we go. So this is the cube, but I think what I want now is to think of the space, unfortunately, as around the center. So I need to do this for everything. Those are the random points. And then also this for X, Y. So X, X and Y also in So let's see here. I don't care about this index thing. I'm not doing pixels anymore. I must have, it's all 3D. I'm not using the color yet, but let's sort of see. Okay. So this is what I'm looking for. I'm seeing this full cube. I want to be much farther away from it. I thought that's what this variable is. Yeah, there we go. There's the cube. Okay, so I see the cube. Now, dare I attempt to now color it with the RGB values? Whoa, look at that. That's pretty interesting. What have I done? Little weird Worley Noise cube. So it looks just like the textures on the sides. I think I need, let's go back to just one color. let's just go back to this idea of an N just as one color. And let's fill it as 255, but have, I lost the mapping. Why did I lose my mapping? I just want to have one. D. Keep this as N. But what I want is for that mapping to be 255, comma, this is the alpha, basically. I want it to be the alpha. So I want the transparency to be based on the noise itself. I feel like I'm not seeing through it in the way that I had hoped. Don't need to show the voxels. Can you now set the alpha of every voxel that is black to 0? That's what I think that I've done. Maybe I want the colors, but also include, let's just try this for a second. Yeah, I think, what if I do like additive blending? Ooh, weird. The alpha is not working. I think maybe the order that I'm drawing stuff, something is off. The transparency is definitely not working because look at one side versus the other. Something is weird. What if I give it no fill, stroke alpha? Ooh, that's pretty interesting. And let's go back to N of 0. I think somebody else with a more clever design abilities will have a nicer way of doing this. There we go. This is more like what I was looking for. Let's skip even more. Yeah, this is kind of interesting. I mean, I don't know what I've really got here. But cubes with different sizes. Oh, that's very clever. Okay. Let's try to do the size. So this is the size, which we will have when it's close. The size is large. That skip value all the way down to 0. We're going to have no stroke. And we will have the fill consistently be 255 with an alpha. And this is now the size. I like this idea. Whoa, this is good. Now we're talking. Whoa, that is wild. Okay. I should go back to the RGB colors too. Yeah, this is more interesting here. There's definitely like a weird kind of Z sorting order. Let's just make this smaller and let's see, can I get down to a smaller skip? Yeah. Let's make this zoom out a little bit more. I think actually, I don't know why I can just do this with the scroll. Ooh, except I'm having trouble controlling it. Oh boy. So there we go. Here's my Worley Noise cube. And what happens if I use, instead of an N of 0, an N of 1? give some lights here. Ooh, weird. And okay. I think I'm finished for today. It's 5:45. How are we with our possible Q&A setup? So I will remind you. Let's go back to the original Worley Noise. I'm going to comment out the save frame function, and I'm also going to reduce the size down to like 640, 360, and let's just make 20 points. Yeah, there we go. So this is a nice version that will run in real time. Invert the cube size. That's kind of an interesting idea. Let's try inverting the cube size. I don't know why I can't open it up. Nope, that's my audio application. Where did it go? Where did the 3D one go? There it is. If we invert it, this would be 0 to skip. I think this will actually look the same. Actually, maybe it won't. Like have a similar quality to it. Yeah, because it's just sort of like the noise is flipped. But now, let's quickly, very, very quickly, I want to port this to a P5.js and just see if it'll run in the browser. Okay? So while we're seeing, it works if you want to do it. Okay, so the Q&A is ready. So what instructions do I need to give to people? We're just going to try this as a test. Maybe we're going to do 1 or 2 questions somehow. See if we can get that working with people coming in via voice. And let me know, it's ready. So you have to be in the Discord if you want to participate, and this is going to be sort of random right now. I think what maybe, I don't know if we should limit it to like people in the supporter chat or whatever. I'll let the people in the Discord work that out. Probably should test this. The idea was to test this with the smaller YouTube members first, but what are you going to do? All right, so let me go to the browser, and let's go to the P5 editor. Let's log in. Why am I not logged in here? Oh, there's a cat. Okay, so now let's just paste this in. And let's see if we can get this to work in P5. So what do I need to change? So this is just an array. This is just a plain old variable. This now, we can just do this. We can just hard code this as 20. This is create vector. This is function draw. Function setup. Create canvas. How am I doing? Background 0, load pixels, let, here, okay, okay, equals features index I, and the distance is between x, y, z, and v dot x, v dot, that still is the same. Sort, I think, still works. Let. Now here's the real, the big thing that's different is this. So this needs a ×4 because unlike in processing, the pixels in P5.js have 4 spots. All right, so I'm just gonna pause this for a second to let you know what's happening with the Q&A. So if you are in, here's a link to the Discord that's going in the YouTube chat if you haven't joined. Go to the Q&A talk channel in the general section. Then you need to go to the bot talk channel, and then you need to send a message which is $Q space join, and wait for your turn. I'm going to open up Discord here at some point, but that, I guess, and maybe there's people there chatting who can help you. Index. Okay, whoops. We're going to take calls here live on the coding train. This is going to be new. Just voice calls right now. We can do video at some point. Then I need to say pixels index plus 0 is the red value. Plus 1 is the green value. 2 is the blue value. And then I need to set the alpha myself, manually 255. So unlike in processing where you put a full integer color into a spot in the array, what you do here is have each, the RGB and alpha values are in separate spots in the array itself. And so for the x, y's, you look up that point and multiply it by 4. I think I've got everything here. What did I miss? What's the chance that this is going to work? I would put it at less than 10%. But we will give ourselves a little drum roll nonetheless. They got a little louder for effect. Oh, okay. Ah! This is a really weird problem that happened that I know what it is. Very unexpected. I'm surprised how well this worked. So this is a high density display, a Mac Retina display. And so in order for, there's actually double or quadruple the number of pixels than the actual 644 by 8 specified. So I think I just need to manually say, oh my God, and I've killed this computer. But I need to manually just say pixel density 1. And you know what, let's just make this really small right now. 200 by 200, just to see that it, let's not, okay. Right. So you can see how slow this is, even just at 200, 200. But it is working. Let's go down to 100, 100. Yeah. So you can see this pixel manipulation stuff is really, really slow in the browser. So this same exact sketch at 100 by, pixel resolution of 640 by 360. Now there's a lot of inefficiencies in what I've coded that could be optimized, but you can see how kind of chunky the animation is, as opposed to, and I can barely even tell it to stop, as opposed to in, oh, you know what? I'm running a lot of other stuff on the computer. That certainly doesn't help. But as opposed to in processing, where this has no problem to render at a fairly reasonable frame rate. So porting this to WebGL using shaders somehow to operate the pixels, there's a lot of ways that this could be could run really fast. And I suspect if I look for like Worley Noise, WebGL, I'm going to find some really nice demonstration. Right, and this I think is what I was referring to. This book called The Book of Shaders. Here we go. We can see here's that same algorithm running, or a similar algorithm running in WebGL with shader code. Let's see what happens if I get further down. Yeah, look at that. And this, by the way, is what happens when you move the points around more thoughtfully. Oh, these are just like, how are they moving? They're sort of doing like a nicer random walk. This is the other thing that I really want to do. I just want to move them according to some particular algorithm like flocking. Let's do that. Let's just add the flocking algorithm real quick. Or should I do the Q&A? Well, flocking is kind of overly complicated. All right. It's okay. We're going to make this happen. This is worth it. Okay. Worley Noise. So let me draw these features just so I see them. Feature Z, why did I get, negative width. Negative width divided by 2 to width divided by 2. There we go. So this is where those feature points are. What if I also move those feature points? So I could just go back to the random motion. And that just makes it like jiggle a lot. I want it to feel much more smooth. So what if I get any of my nature of code examples? Send them off in a random direction, then bounce off the edges of the screen. That's probably what I should do. Let's just do that. That's fine. Let's do a random direction. I just need a particle class is the problem. So let's look at what examples I have that'll do this nicely really fast. Under agents, perhaps. Flow field, stay within walls. This is a good one to do. Arrive, path following, separation, flocking. The separation one might be kind of interesting. Like let's look at, I mean, I could do the wandering one also. Oh, the camera went off again. I wonder why have I not set on this camera where I must not have set the like stay on forever property setting. Battery exhausted. Oh, I haven't plugged in though. Ah, that's what's going on. It should be plugged in. Oh, is it like, was the cable loose? That's what's going on. Let's give it a minute to see if it charges up. But yeah, it's charging now. I had this camera plugged in, but that's why it was going off. Okay, should be fine now. Cable was loose. Ooh, there we go. All right, let's just do, so this is, I'm gonna leave this as an exercise to people watching this. I have so many different kinds of motion behaviors, but I'm gonna go with something much simpler. And let's just look at so an example from chapter 1, which is like bouncing ball. Let's just grab this one. So I'm gonna get this class, which just has, it's a nice like quick bouncing ball class. And I'm just gonna call this a particle. And let's just change this to particle. And we wanna make this a random vector. So this gets, these each get a random position. Oh, right. Okay, hold on a sec. Hold on, everybody. This is what I need. Right? These are going to become particles now. So this is going to go in the particle class. The velocity is going to be a random velocity. And then this looks weird. Okay, I don't know what's going on here, but this is fine. And then we're going to update the velocity. It's going to bounce off the edge. We have a display function in case we need it. So now the features are particle objects. And there are 20 of them. They're particles. The position gets picked inside. And then now this is a particle, or actually it's features dot position. And so all that stays the same. And now for each of the features, what I can do is I can say particle P equals features index I, and I can say P dot display. So let's just make sure this works. So there we go. So these are the particles, and now it's doing the noise based on those particles. And now if I call update on them, they should move. And I want them to move much faster than this. So let's give them, let's increase their velocity to like multiply them each by like 5. And there we go. Now it's sort of hard to see what's going on because let's not draw them. Looks like it's running much slower. Yeah, so in addition to, oh, the camera went off again. But in addition to the slices, they're actually moving. Let's get rid of the slices for a second. Let's just override. Let's not increase the angle. Let me just give you just the computer for a second. I'm going to get rid of the slices, so now you can see this is what it looks like with them moving. So anyway, you see now many more possibilities here. Let's try. Okay, the Q&A is ready. We're gonna switch. We're gonna try the Q&A. So I'm gonna try to go to just my camera for a second, even though I know the camera went off. It's charging. Hopefully, it's I guess not charging fast enough. So let me see first. I'm gonna go into the Discord on this computer. I've got to do a couple things. Wow, it's getting dark in here in a weird sort of way. Okay, so let me open up the Discord. We're going to try this Q&A, everybody. Get looped back. Discord is on. So now we should, if I go open up Discord, this is very exciting. This is a very exciting moment here. Our first Q&A with live talking. Where should I go here? Should I go to, so I guess I can just leave this open because I'm in streamer mode. I need to go to the coding train Q&A. There's lots of notifications. I should go to which channel? Which channel do I go to? Bot talk? No. Voice chat? Q&A talk. So I'm going to join that channel.
Hello, Dan.
Okay, so I think your hello, Dan, just went out through to the live stream. Can everybody thumbs up in the live stream that you heard a hello, Dan? I also hear a typing. It's in my ear, and I see. I'm just going to show you the way I have this. I'm using a piece of software called Loopback. I'm going to close Discord and let me open up this again. So this is the software that I'm using, and basically I'm taking the audio from Discord and it is going into USB capture, which is what's going to the live stream, but it's also going here into my earphones. Is that a word? Earphones?
I think it is.
And then and by the way, this is coming from the soundboard. So if I play this, you can see all these things are happening all together. So I'm ready for some Q&A. I don't know how this is going to be managed, or if I should be having the Discord open. I could also look at the Discord on my computer over here. Let's try a couple questions. It says he's louder than me. Whoa.
Wow, there we go.
I had a suspicion that it might be Simon who joined first.
I joined.
Yes.
Yay!
We hear the
Go ahead,
laughter of
Simon.
Simon. Go ahead, Simon.
Okay.
So, what is your question, Simon?
Nothing. I'm gonna.
Okay, I'm gonna go to the next person.
I'm hearing that.
Maybe I'm gonna do a.
I'm hearing that audio is very loud. So let me see if I can. I can turn this down.
Maybe I'm gonna do like some sort of like follow-up question on some sort of question that gets asked. Oh.
I think I did think everybody getting to hear Simon's voice is an exciting moment. And if you haven't checked out Simon's channel, I think if you just search Simon Tiger on YouTube, probably it will come up. I can confirm that that's the case by just typing in, going to YouTube, typing in YouTube, Simon Tiger. Let's see. And here we go. This you can find Simon's YouTube channel where he has lots of exciting coding videos right here.
Exactly. Before we go to the next person, I see there's a lot of people in the YouTube chat still asking a question or not too sure about how to join. So for those people, you can join the Discord, and then in there, just go to the Bot Talk channel, and there'll be a little text in there how to join the Q&A.
And is the audio balance better now would be a question. Unfortunately, it's a little bit quiet for me, but I lowered it. I'm sure I can I'm sure I can manage that. I can still hear it, so it's fine. But I'll work that out next time. But hopefully the audio balance is better.
Some sort of cacophony. Because I have the live stream on.
Actually, I can turn this down here. Hold on, and then turn this up here. Kobe, can you talk for a minute again? Let's see how it is.
Yeah, sure.
All right, so that's.
I'll just give you some tests out. So 1, 2, 3 tests.
All right, so that's much better in terms of my volume, but I'm curious what the levels are for the audience on the live stream.
I think we'll have to wait. For
Yeah, we have to wait about 30 seconds.
I see one reaction in chat saying now low.
No, it's low. Interesting. So that's easy for me to raise it. So I'll just raise it up a tiny bit, and that should probably be a little bit better now.
There we go. Okay, I think we might move on to the next person.
Yep.
Then. See what question they have.
Hello.
Hello.
Hello, Nikki.
First off, I want to say I'm German, so I'm sorry for any mistake that I make.
You're doing great. Where in Germany are you?
Thanks. Hessen, in Wiesbaden. I don't know if you know about it.
I've been to Germany, but I spent most of my time when I was there in Berlin, so that's my American knowledge of the geography. So what's your question today?
I want to know if you know about two-sided rendering, because most triangles in 3D rendering are rendered on two sides. So one is invisible, or both are visible at the same time. And if you know about it in processing, that could be the problem why you couldn't set the alpha to 0.
Ah, okay.
In the Worley cube. That was my suggestion in the chat.
Okay. So if I'm here in and if you won't be able to see my screen where I am, because the live stream you're like 30 seconds ahead of the live stream. But is that the two-sided rendering? Is there like a setting that I can change in processing that would you're saying that would just fix this?
I don't really know.
Or you're just like the concept of you're telling me about the concept of two-sided rendering, and you're wondering if that's something that's the reason. Yeah. So I think yes, I think that is the case. I also recall that there is a way that it's having this issue before, and it could also be related to the order by which I'm drawing things. But your idea sounds right to me, because it was like when I just looked at the other side of it. So if I open up the cube right now, it looks very different on one side versus the other. You can see it's dark on this side and bright on this. So yeah, I think you're probably right.
So I think that was because from one side it's passing through, so you can see the entire cube from one side, but from the other side it's like a 2D plane, because you can't see through because the alpha is still set.
Yeah. So I think that's probably right. To be honest, like I do so little 3D stuff. But I guess if I search like two-sided rendering processing, we might get some. I guess. Well, I probably need to type in processing.org. We might find a solution eventually. Excellent. Thank you for that suggestion. I think you're probably right that that's what it is.
Okay. Thanks.
Thanks for calling in. Remind me your name again?
My name is Nisa.
Nisa?
Yeah.
Awesome. This is fun. This is like a coding talk show. It probably would be good for people to join in video in some ways, but it's nice to hear people's voices. So thanks. Should we move on and try another question?
Yeah, sure thing.
Discord moderation, magical people.
Well, bye.
Bye. Thanks for calling in.
No problem.
This is still running.
I think
by the way.
David might have slightly broken the bot.
Oh, that's okay. Well, this was, I think I'm going to have to wrap this up pretty soon anyway. This was a bit of a test to sort of see how it might work to do like a Q&A. I kind of wanted to do some kind of like special thing to celebrate 1 million subscribers. Sort of, I have to admit, it didn't really happen because I'm just going to mute this for a second.
Go ahead.
I'm hearing a lot of noise in the chat. I guess I should keep this open. Oops. I don't know, with the global crisis that we're all finding ourselves in, it didn't really feel much like celebrating 1 million subscribers, but and I've just been sort of focused on other things like getting through the day and doing a little something every day, dealing with and helping family and friends out. But at least I got this live stream out, and we're getting this sort of test of this voice system. What might make more sense is to do this as a separate thing, maybe just once a month. It could also be something that I do just as with a smaller group as a benefit to people who are patrons or members. I'm certainly not in the mood to ask people to join right now. I know so many people are struggling financially and out of work, and there's no need for anybody to join the coding trade right now. But this is a nice thing to be able to do. Are we set up to maybe try one more person, or should we wrap it up for today and be happy with our test?
The next person sent me the question he wanted to ask because he doesn't have a microphone.
Oh, okay.
His question is, what coding languages do you know?
Ah, okay. And who am I talking to right now?
Called Tardigrade.
The voice was Solarliner, one of the moderators.
Solarliner. Okay.
Yeah.
And the question, what coding
was asked by Tardigrade.
Yeah. So what coding languages do I know? I would say that let me try to do this in order of when I learned them. So the first programming language I ever did was in elementary school in the 1980s, was BASIC. Basic programming language on an Apple II Plus. Then I didn't program again at all until maybe middle school or high school. I think I actually learned some assembly language. Then I didn't program again at all until I was maybe like 22 or 23, and I took like an evening course, kind of guessing here, in C. And I was kind of like, not for me. Then I went to graduate school at ITP, which is the program where I teach now at NYU, and there I learned the Lingo programming language, which was invented by John Henry Thompson. If you're not familiar with John Henry Thompson, you should be. Luminary in the world of creative coding. This is John Henry Thompson. I'm pretty sure if I go to videos, you'll see he came and was a guest on the coding train at one point. But invented the Lingo programming language, which was the language for Macromedia Director. So that's where I really first was programming, because I was doing it intensively in an intro class. From there, I learned Java, I learned C and C++. So I know all those languages that I described, but I would say probably Java is the one that I spent the most time with, and then started working on, after I learned Java, was working with processing, which is built on top of Java. And more recently, in the last 5 or 6 years, I've been learning and doing stuff in JavaScript. So Java and JavaScript are the ones I probably know the most. And Python I can make my way around if I need to. I'm often like finding Python scripts and running them as a part of a project or a thing, but it's definitely not my expertise. So that's my long-winded summary of all the programming languages I know.
I think there might be a follow-up question, Colin.
Okay.
Never mind. It's just Tardigrade thanking you for answering the question.
Excellent. All right, so, the camera keeps going off. Now, is it because of the battery, or is it actually, I think it must be that it's not, that I didn't have it sitting and charging, and the battery is just very, very low. I'm turning it back on. So I think maybe I'm going to wrap up for today. I don't know if, battery exhausted, yeah. I don't know if, I have an idea. Here is another camera I have. Oh, there I am. This is the camera that I had on the drawing. Whoa, very close
up. Would you be up for one more question? We had one more person.
Yeah. Let's have that question come in with my giant head.
There we go. Let's see if that works. Go ahead, David. DC6, are you able to speak?
Second question.
DT6? It might be broken Give me 2 seconds. I will do a manual
I've
fix.
unmuted
right
him manually, so if you want to ask a question, go ahead. DT.
You should be able to speak now, DT6.
This
This
camera is actually pretty good quality.
Some technical difficulties, apparently.
He is able to speak. He's not muted currently, so I think it might be a mic issue, unfortunately.
Yeah. You're welcome to type your question. I'm happy to try to answer it. But while we're waiting for maybe the question to come in.
I can read it aloud.
Okay, great. While I'm waiting for the question to come in, so this to me, as much as it took me like a half an hour to get a little bit more comfortable and get over my own like anxiety and confusion about live streaming from this setup, I think that this went pretty well, and I'm hoping that I can get back up and running with live streaming once a week. I don't think my like recording to disk stuff worked really well, so I don't know if the Worley Noise example will end up being edited into its own video that would then have a Coding Train page associated with it. So if you're not familiar, if I just go to the Coding Train website, all of the coding challenges and the Coding the Cabana videos and other tutorials as well, if I go to any given page, like let's go to one that I know has a bunch, like maybe this raycasting video. If I go here to the challenge page, you'll see all these community contributions. We have a system for you if you make your own variation of it to collect all these. But I don't know that I'll have a Worley Noise page, but I would love to be able to collect all the Worley Noise projects if people make variations of it, and I certainly will upload this code. So let's think about how we could share that. The Discord is certainly a way, so maybe we can have a discussion in the Discord after this stream is over, you know, and create a web page just for the Worley Noise, because I do think the Worley Noise code opens up a lot of possible variations, and I'm sure a lot of people watching will have clever ideas about how to visualize it, even without an animation, just to sort of like render a high-res version of the image with thinking about color and texture in different ways. So I'd love to be able to collect those. So if you're watching now and you're not in the Discord and you want to discuss that, join the Discord. We'll figure out a way to collect those. We could also, obviously, you can share those with me on social media. At Schiffman on Twitter, at the Coding Train on Twitter. There's actually a Coding Train Instagram, the.coding.train. I would really love to see if you're working on something with Worley Noise from this. Also, maybe what I can actually do is just kind of redo this, but with the Coding in the Cabana setup. So I could like sort of refilm the Worley Noise, just sort of walk through, just do it again, and sort of edit it together to make it its own standalone video. Okay. I hear a voice.
Okay, 6. Yeah, it's background noise for me. I'm sorry. DT6 question is, where is the Ray Marching Coding Challenge?
Where is the Ray Marching Coding Challenge? I don't think I have a proper Ray Marching Challenge. I have this Ray Casting. Kind of the same thing, but different. And I have this rendering raycasting. So these would be the ones. Oh, you don't see what I'm looking at. Ugh. My whole setup is kind of broken right now. But there's these 2 challenges that you could take a look at. If you're interested in more sort of like proper ray marching, I believe that Sebastian Lag has a video tutorial about it. Coding Adventure Ray Marching. So if you're not subscribed to Sebastian Lag's channel, it's really excellent. There's lots of really wonderful tutorials and, well, I don't know if the tutorials is the right word, but sort of explanatory video essays in a way about different algorithms which done in Unity with 3D. So, but the other thing that I'm really planning to do soon, I was thinking of doing it today, is and speaking of Sebastian Lag, is marching squares. Marching squares is a wonderful algorithm to create. I have a video where I made these metaballs pattern, also known as meatballs. But you can create this kind of animation with the marching squares algorithm as well. So I don't know if that really answered your question, but
there
we'll
was
definitely take
a
look for that.
follow-up by Simon, who says you do have a Ray marching live stream. It just hasn't been edited into a video.
Really?
Apparently, live stream 177.
I just like can't remember this at all. Look, now there's double me. Okay, you can see this is this camera, right? Ooh. Ray marching live stream 177. Yeah, I think this is. Oh, you know what though? I think I just. It's just the title is called Ray Casting and Ray Marching because I think if my memory is correct, I think I didn't know what I was doing. And it was like, oh, I want to investigate this. Are they the same thing? Are they different? And, you know, to be honest, right now, I wouldn't be shocked if I got it kind of mixed up. But my memory is that the algorithm that I implemented was more specifically related to the term Ray casting, and Ray marching is a little bit different. So there's somebody in the Discord voice channel who knows precisely the answer to this, could just pipe in and fill in all these gaps. But I'm pretty sure that the only thing that I did are those two particular examples. Milan, by the way, in the chat writes, what is the best way to teach my nephew programming? So I would say, first of all, the age of your nephew is a major consideration. But I would say if your nephew is 12 or 13 and up, certainly the this playlist of mine, and again, I'm not suggesting that my stuff is the best for teaching programming. It's just that I happen to know what's there. But this particular playlist, Code Programming with P5JS, is meant for total beginner. So, you know, I wouldn't necessarily suggest this for elementary school age, although certainly some, you know, viewer Simon was probably coding this stuff like in an elementary, much younger age. And really, if an elementary school student is capable of typing, then I think following this is possible. But certainly middle school and high school and up, all the way to any age, really, this is my beginner playlist. For elementary school age, you know, I would take a look at Scratch. And I know that Scratch has been doing some new initiatives with maybe sort of teaching at home and that type of thing. But Scratch is a block-based coding environment. I did actually a little weekend live stream last weekend doing some stuff in Scratch. It was not a proper tutorial, but you could take a look at that as well, because I did it with my children. It's right here. So you could look at this 2-hour and 40-minute live stream where we programmed in a couple projects in Scratch. Okay, so this I think I'm gonna wrap up the. I'm gonna mute the audio in my ear, if that's all right.
That sounds like a great idea. I think we had all the questions.
So thank you, Kobe and David and Nathan and anybody else in the chat who was helping with this test. My intention was to do a kind of like more of a rigorous test with a smaller group, but why not just try it here live? This live stream is wrapping up. I would say one thing that would make me inordinately happy, if that's the proper adjective or to use right now. What's this over here? Oh, top secret control panel. This is my top secret Discord control panel. So I didn't even know I had this. Mute, deafen, so many possibilities. But would be to see, let's come up with a hashtag. I'm gonna go to, let's just go to my camera here. I'm gonna go to, I just wanna see if I'm logged in on Twitter as anything. I'm not, so I can't post anything. Let's come up with a hashtag, a Twitter hashtag for Worley Noise. And I realize there's not everybody's on Twitter. It's not the best way to share this stuff, but I'm gonna go out through the evening and weekend, and it would make me really happy to see if people make stuff with Worley Noise. So what's a good hashtag? David suggests all the noise. I think we might need something that's related to Coding Train. What if we did like choo-choo noise? Whirly choo-choo? Whirly chew? Chew noise? Noise chew? Sounds like noisy foo. I don't know. Coding Worley Noise. That's pretty good. Whirly Train. Whirly Train is good. Let's do Whirly Train. Twitter.com hashtag, and I'm afraid of the internet, so I'm gonna just go back to my camera here and look at Whirly Train. No results. You could be the first. You could be the very first to have a Whirly Train hashtag. Let's see if I can manage to post something. Noisy little whirly train. Whirly bugs. Let's go. Let's see if I can manage to log into my Twitter here. What's the chance I can do that? It's going to take me a million years through all my different protections. It's so hard for me to log into anything because I have password manager, I've got two-factor. I can barely get into my Twitter. I'm going to post my video though and see how it looks. Just give me a second. Maybe you will post something before me. We'll see. I'm going to look at my password here, which is some crazy sequence of characters. 46. Oh, you know there's a 46 in my password. Good luck now deciphering it. Shoot. I didn't even type it in correctly. You know what would actually be good is to always have the voice channel open in Discord, and for like in emergencies, people could like say, hey, your mic went off or something like that. Whirly Pickle. That's pretty good. Okay, wait. I need an authentication code. Did I get it? Yes. Do we have any better hashtag suggestions? Let's post. Okay, here we go. Whirly Train. Is that what we're going with, people? Whirly Train. Whirly Pickle is pretty good. Whirly Train. Pickle really needs to go out for a walk. Why is Dan? Oh, everybody's behind Whirly Train. Whirly Train. Whirly Train. And I'm going to get my video. I'm sure compression will kill it. But let's look at the, let's see if, all right. I am now about to tweet. Go back to this Whirly Train. Thanks for watching the live stream today, everyone. I'm having trouble writing my tweet. Could somebody help me here? Stay home. Be well, friends. Take care of yourself and each other. Let's give ourselves some nice emojis. Is there a pickle emoji? That's going to be misinterpreted. A dog. Let's see. There we go. And rainbow. There we go. And some stars. I think that's enough. I think I did my duty. All right. How's this look, everybody? Oh, Whirly Train. Share yours, Whirly Train. Whirly Train. Okay. I think this is good. I am going to post this tweet and say goodbye to all of you. I will let you enjoy some time with Pickle. on my way out. Let's see if I can. Oops. Whoops. There's Pickle. And see you soon. Goodbye, everybody. Thank you so much for tuning in. Thanks for bearing with me as I try to get used to this setup and figure out what it is that I'm doing and how I'm continuing the work that I do, and also being mindful and conscientious of all the struggles and difficulties everybody's having, and bring something good and useful and appropriate, and say all the right things and be nice and everything that I want to be, which is just to be a kind, helpful person. And so your feedback is welcome, and I look forward to seeing you on the next live stream. I wish I could just do this every day, but I have a lot to take care of at home, but I'll do my best. And please, your messages and thoughts and sharing your own visual ideas are always wonderful, and I really appreciate it. I'm going to play you out with some of my ridiculous music, like the This Dot song. As always, I always forget the this. Which I don't hear anymore. This dot, I'm gonna do this dot, this dot. Now I hear it. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this. By the way, if the Discord voice channel is still going through, I should turn that off. Okay, Discord voice channel is off now. Now you can talk. I can hear you. Oop. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. How long is this? So this is random, this is noise, Worley Noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Worley Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6. Oh, my microphone is still on. I'm gonna mute my microphone now. 8, 7, 6. Well, this is like Worley Noise performance art. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot. 2, 3, 4, 3, 4, 5, 6, 5, 4. Well, this is like Worley Noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Worley Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. This is Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. This is Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. This is Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. Worley Noise that is. Worley Noise. This is Worley Noise that is. Worley Noise. This is Worley Noise that is. Worley Noise. So this is Worley Noise that is. Worley Noise. Apparently. But with Worley Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Well, this is like Worley Noise performance art. Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that, and look what I get. I'm really losing my mind. Okay, let's do it. feel just sort of like a nice feeling of relaxation. Everything's gonna be okay today.
Dream is not broken, it has not frozen. This is a wonderful thing. Okay, we're gonna do it. I'm really getting to something. I need my sound effect. Unicorns and rainbows and cupcakes. What else is there? Unicorns and rainbows and cupcakes. That was invalid syntax, I forgot. There was one other thing here that I think is important that I will use continuously over and over again in all sorts of text generation analysis things. That I will use continuously over and over again. The first thing I need to do is, yes, kittens. Kittens, kittens! I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens and Das Vidania.